Hello, this is going to be the key for the Unit 2 review for calculations. So let's just jump into it. Number one is saying that Ryan was running to make a touchdown moving at a speed of 8.80 meters per second. He ran for 30 meters before he was tackled just short of the goal line. How long did it take to run those 30 meters? If I'm going to solve these, the first thing that I'm always looking at are the words and the units of my numbers. So if I have meters per second and meters of, I went and I tried to really highlight to let you all remember that anytime you have a distance over a time is the unit for speed or velocity. A distance over a time squared is the unit for acceleration. Here I have a distance over a time in my number 8.80 meters per second. So that could be either a speed or a velocity. Again, it does not matter really which one I use. They both mean how fast. It's really just trying to determine whether or not you have a direction associated with it. So here I'm going to just start with speed. I'm going to write that the average speed is equal to the change in distance over change in time. I start with my equation, and then I write my knowns and unknowns. Average speed equals, change in distance equals, change in time equals. I look at the units for each, trying to decide which one goes where. If I have 8.80 meters per second, that has to be my speed. Change in distance, 30.0 meters, and change in time is my unknown. If I am doing that, and I'm trying to make it a little bit thinner, then by itself, I have to immediately rearrange my equation for change in time. So I write average speed is equal to change in distance over change in time. I want change in time by itself, so I multiply both sides by delta t times delta t. I get average speed times delta t is equal to change in distance. And then I divide both sides by the average speed in order to get change in change in time by itself. So my final equation is change in time is change in distance over average speed. Done. Then I just plug it in. So change in time is equal to the distance, 30.0 meters, divided by 8.80 meters per second. I solve on my calculator over on the side here, so 30 divided by 8.80. I get 3.40909 repeating. I decide how many sig figs I need. I need 3 here because of 30.0 and 8.80 both having 3 sig figs. So I count 1, 2, 3, draw my line, my 9 rounds up. So I would have 3.41 seconds for number 1. Number 2, calculate the acceleration of a car that is able to go from 42 meters per second to 110 meters per second in 0.13 minutes. Same exact thing. I start with my equation. Acceleration is VF minus VI over T. My acceleration, velocity final, velocity initial, and time. Acceleration is my unknown. Final has to be whatever velocity I end at, 110 meters per second. 42 meters per second is my initial, and time is 0.13 minutes. Something that I noticed right off the bat, I want you to think, if these are measured in seconds and my time is measured in minutes, I can't plug it in yet. I have to convert. So what I am going to do, I'm going to convert minutes into seconds first. I want 1 minute times 60 seconds here. So I'm going to do 0.13 times 60. I get 7.8, which is still 2 sig figs, which I'm perfectly fine with. So my new time is 7.8 seconds. Then I just plug in. I don't need to rearrange here because acceleration is already by itself on one side of the equal sign. So I have acceleration equaling 110 meters per second minus 42 meters per second divided by 7.8 seconds. So I do 110 minus 42 first. I hit enter to get 68. Still in the ones place, still good, divided by 7.8, and I get 8.717 of 9 numbers. Again, sig figs, I have 68 divided by 7.8. I need 2 sig figs, 8.7, chop off the rest. I get 8.7 meters per second squared for number 2. Okay, high-speed train travels with a displacement of 245 kilometers for 2.5 hours. Calculate the average velocity. Velocity is equal to the change in displacement over change in time. Velocity equals change in displacement equals change in time equals. Velocity has to be my unknown. Displacement is 245 kilometers. My bad, 245. There we go. And my time is 2.5 hours. I don't need to rearrange or convert anything here because everything is going to match. So I just plug in. Velocity is 245 kilometers over 2.5 hours of, let's get a calculator, 245 divided by 2.5, and I get 98. I need 2 sig figs off my 2.8 or 2.5, so 98 is perfectly fine. Kilometers per hour. Done. I have a broken down car traveling at 45.7 kilometers per hour for 153.3 kilometers. For how long did they drive? Here, again, I immediately notice the kilometers per hour. I know that that is a speed or velocity. Here, again, though, I'm just going to write it as speed. It doesn't give me a direction here, so I'm going to use instantaneous speed. Speed equals distance over time. Speed, distance, time. My speed is 45.7 kilometers per hour. My distance is 153.3 kilometers. My time is my unknown. Here, I do have to rearrange. I need to solve for time, so I'm going to start by multiplying both sides by time. Cancels. T times S equals the distance. I want time by itself, so I divide by S, and I get T equals distance over speed. Now I plug in of time is going to be equal to my distance, 153.3 kilometers, divided by my speed of 45.7 kilometers per hour. The kilometers cancel, and I am going to be left with, let's get our calculators, 153.3 divided by 45.7. And I get 3.354485, numbers, 3.354485, numbers. My calculator, I need sig figs, so this number has 4 sig figs, this number has 3 sig figs, meaning I need to round it to 3 sig figs. 1, 2, 3, everything after the 4 gets chopped off. So I have a time of 3.35 hours. But the problem is, I'm trying to figure out how long he drove in minutes. So once I have my answer, 1 hour is 60 minutes. So I'm just going to multiply that number by 60. So 3.35 times 60. Answer with 3 sig figs is 201 minutes. Done. All right, number 5. Brian drove his car at 60.6 meters per second for 4,960. What distance did he travel in kilometers? Again, there's a speed. I don't have a direction. I'm going to use speed. Speed equals distance over time. Speed is 60.6 meters per second. Distance is my unknown. Time is 4,960 seconds. I need to rearrange. So I need distance by itself. I'm going to multiply both sides by t. So t times s is equal to my distance. And now I can plug in. I make sure that my units match beforehand, but both of them are in seconds as their time value, so I'm still fine. I take my time, 4,960 seconds, 4,000, multiplied by my speed of 60.6 meters per second to solve for my distance of 4960 times 60.6. I get, ooh, that's gross, 300,576 meters. So I need sig figs now of this number has 3, this number has 3, therefore I must round to 3 sig figs. My third sig fig is that 0, the 5 rounds up, and mind you, I do not cut them off here because they are before a decimal. So my end number is 301 and then 30 meters. But I'm asking what did he travel in kilometers? So I have a conversion, 301. So 300,000 meters times I know I want meters into kilometers, and there are 1,000 meters in 1 kilometer as given by the conversion factor. Meters cancel, so I do 301,000 divided by 1,000, which is just equal to 301 kilometers. Done. 6 is Kate pushed the car down the hall. That's got to be hill. Starting at rest and reaching a final velocity of 1.32 meters per second with an acceleration of 4.34 meters per second squared. How long did the car travel in minutes? Of acceleration, it's Vf minus Vi over t. Start listing our knowns and unknowns. I'm looking for meters per second squared for my acceleration. Vf is my final velocity. This has to be 1.32 meters per second. Vi is my initial. It says at rest. Since it's at rest, Vi is 0. And time is going to be my unknown. So if I want time by itself, I start with my equation. A equals Vf minus Vi over t. This is a term. So I'm going to multiply both sides by t first. I get t times a equals Vf minus Vi. Then I'm just trying to solve for t. I need to get rid of a. Divide on both sides. T equals Vf minus Vi over a. Then I solve. T equals Vf 1.32 meters per second minus 0 meters per second divided by the acceleration, 4.34 meters per second squared of, let's solve. Again, the top is a term. I'm going to put it in parentheses, but since it's divided by 0 or subtracted by 0, it doesn't really matter. I get 0.30430414 numbers as my number. I need, again, 3 sig figs for this, so it's 0.304 seconds. But I'm not wanting seconds. I want how long it's traveled in minutes. So I start 0.304 seconds times 60 seconds in 1 minute equals, and I can solve. So 0.304 divided by 60, and I get 0.00506 repeating. Again, 3 sig figs, beginning zeros don't count. So, if it's 6 repeating, there's another 6 here. 6 rounds up to a 7. It would be 0.00507 minutes. Done. Okay, number 7. Ron's car accelerates at a rate of 2.60 meters per second squared. How long does it take for the car to accelerate from 88,500 meters per second to 96,500 meters per second? Again, velocity or acceleration. Vf minus Vi over t. Acceleration is my 2.60 meters per second squared. I know that again because of its units. My final velocity is what it ends at, 96,500 meters per second. My Vi is 88,500 meters per second. And t, again, is my unknown here, Vi. There we go. I need to, again, rearrange my equation for t. However, it's right up there, and my previous problem, I'm just going to drop it down. VF minus VI over the acceleration. So then I plug it in. T equals 96,500 meters per second minus 88,500 meters per second divided by 2.60 meters per second squared. So 96,500 minus 88,500 divided by 2.60 of, it's going to be 3 sig figs. So I get a calculator answer of 3076.92 numbers. Again, 3 sig figs off of all 3 values. So 1, 2, 3. 7 is going to turn to an 8 after the decimal gets chopped off. 1 number before the decimal to turn into a 0. 3080 meters per second, meters per second, meters per second. We're left with seconds. 3,080 seconds. And last but not least, I have a driver of a car traveling a 15 meters per second, causing a uniform acceleration of -2. How long does it take the car to accelerate to a final velocity of 10? Same thing, acceleration problem, VF minus VI over T. Acceleration is -2.0 meters per second squared of my velocity final is equal to 10.0 meters per second. My pen is dying. VI is equal to 15.0 meters per second. And time, again, is my unknown. I'm going to drag my equation back down, VF minus VI over acceleration. I can plug in my numbers of 10.0 meters per second minus 15.0 meters per second over my acceleration of -2.0 meters per second squared, close parentheses. So I have -5.0 divided by -2.0 of, I get a calculator answer of 2.5. And my sig figs, I need 2 sig figs off of my acceleration. Therefore, you can't see it all. You know immediately my sig figs are fine, and I am left with 2.5 seconds. Done. So there is all of our calculations for our review of Unit 2. As always, please just let me know. And again, thank you.